All right, guys, I understand there was some questions about last night's homework, so I thought I'd do a video to go over the homework, so you'll have the answers and also the video explanations. 10 through 17, I think, was pretty easy for most people, and then the issues started to come. So for number 10, obviously the center of that circle is R. Number 11, a chord, and that's also a diameter. So that basically means the chord has to go through the center point of the circle. So that diameter, which is a special chord, is SU. Number 12 is VU, a radius. It is not. A radius has to go from the center point to a point on the circle. In this case, you just have 2 points on the circle. So that's a chord, and a general chord, not a diameter, but just a regular chord. Number 13, if SU is 16.2, well, that's the diameter. RT is going to be 8.1, half the diameter. The radius is always half the diameter, and that's going to be important in our circumference formula later on. For number 14, they wanted you to identify chords that weren't a diameter, so DE and AE are the chords. Number 15, they tell you that a radius is 14, which means the diameters of that circle, BE and AD, have to be 28, or twice the radius. So 14 times 2 is 28. Number 16, all radii in the same circle are equal. So we can assume that AF and FE are equal, and that's an important concept to remember throughout this chapter, that radii in a circle are always equal. And number 17, they give you another diameter length of DA. So therefore, a radius EF has to be half of that. So 7.4 divided by 2 is 3.7. So now we move on to, I think, the questions that create a little more difficulty. And in terms of these questions, really it comes down to remembering what we learned previously. And number 28, and you'll find out why, when a right triangle is in a circle, the hypotenuse is always got to be a diameter. But according to the picture in the problem, we have a right triangle that's inscribed in the circle. So once again, if we have a right triangle, we can use Pythagorean theorem to get our hypotenuse, which is 17, and then the circumference is whatever the diameter is times pi. Now, a lot of you have probably learned that pi is 3.14. That's an estimate, all right? Pi actually goes on forever. We're going to want to write that answer as just 17 pi, and you just leave it as pi. So that's how you do number 28. Number 33, if one side of the square is 14, I think you can imagine a parallel diameter to that side of the square also being 14. So once I know the diameter is 14, I know the circumference in 33 is going to be 14 pi. So that is the first section of homework. As we move on to section 2, I wrote down 12 through 23 odd. I should have written down 13 through 23 odd, because obviously 12 is not odd. The angles formed around the center point always have to add up to 360. You're basically making a circle around the center point, and we should know every circle is 360 degrees. So we add the 70 and 65, which is 135. We subtract it from 360, and we get 225. In number 15, we add the 135 and 145, we get 280. We subtract that from 360, we get 80. But X, we have two angles that represent the remainder of the distance around that circle. So if those two angles are together 80, then each individual angle has to be 40. As we move on to the 17 through 23, what's important here is to use what you've previously learned. CBD and ABG are vertical angles, so therefore they both have to be equal. And ABD is a straight line, so those angles have to add up to 180. 55, 35, and 90 have to add up to 180. 125 and 55 have to add up to 180. Those are linear pairs. And once I have my central angles, the central angles equal the arc they create. So arc AC is going to be equal to 125 because it's created by a central angle, it's 125. CGD, I got to go in that order. C to G to D, so that's 125 and 55 and 35 and 90. That's 305. ACD, I got to go in that order. AC and D, 125 and 55 is 180. And then AC and F, I have to go in that order. 125 and 55 and 90 is 270. As I move on to 27 through 35, I drew that same picture, and I find the angle measures the same way. The middle angle, I guess, unfortunately, I did not label it. It should have been L, but FLG is 40 degrees. So therefore, KLJ is 40 degrees. KLG would be a linear pair, so 140 plus 40 is 180. So really what we're doing is we're taking what we learned previously and applying it, and that's an important thing to be able to do in math. So now ArcJH is 60, ArcJFH is 300, GHK is 180, GFK is 320, and HGF is 120. Our central angle equals the arc that creates it. In our final problem, we have to set up a proportion. The central angle is always over 360, and the arc length is always over the circumference. The circumference is going to be 4 pi, b as in 36. We're told the radius is 2. So therefore, if we double the radius, we get the the diameter, not denominator, but diameter. So the circumference is going to be the diameter times pi, which is 4 pi. Since my radius is 2, I double the 2, and I get 4 pi. And I'm trying to find my arc length. So 130 over 360 equals arc length over 4 pi. I reduced it to 13 over 36, and we cross multiply. 13 times 4 pi is 52 pi, equals 36 times the arc length. We divide by 36. 52 over 36 reduces to 13 over 9, and obviously we're multiplying it by pi. So those are the notes to the homework, or the answer key to the homework, as well as the explanation. Hopefully this helps, and if you have any questions, please reach out.